Good evening. What's going on there, folks? Earthmaster here on the live stream. It is July 29th, 2021, about 7:10 p.m. West Coast time here in California. And taking a look at the earthquake 3D globe, still shows that significant major earthquake up there in Alaska from last night. An 8.2 magnitude earthquake striking along the Aleutian Trench. You can see it right there in the, it was in the blue circle right there. It's going to be the first earthquake down here at the very bottom here. Excuse me. Striking at about 32 kilometers below the surface. That's where this earthquake struck. In a subduction zone called the Aleutian Trench, the North American and Pacific Plate boundary. A major area when it comes to producing some significant sized earthquakes here. This thing kind of triggered a little tsunami scare, which ended up not producing a tsunami, at least not anything significant. Of course, if you were watching the live stream last night or the update video, you had seen that, let me go ahead and see if we can show you guys real quick. The National Data Buoy Center, they're still all in event mode. Within the last 24 hours, that is. And you can see how this pretty much lit up, this 8.2 earthquake lit up the entire ring of fire up here to the north, including a little one in Hawaii, on the south side of Hawaii, and also over here in the Atlantic. Now, I was pretty puzzled when I went to bed seeing this, because I knew that these things basically just lit up only a few minutes after the earthquake. So I knew that the wave, if there was a tsunami, had not reached out that far yet. Instead, it was just basically a ground signal from the earthquake itself. Kind of a wave motion, if you will. Not from a tidal wave, not from a tsunami, but just a general wave that an earthquake will produce. And I'm pretty sure I felt it here in Northern California a few minutes after that 8.2 struck. I was awake. I just felt like I was kind of like on a waterbed, but very slow type wave motion. Not very fast, but just kind of like a wave, but very slow. And also I talked to a couple other people that felt the same thing, so I wasn't imagining things. It was a very powerful earthquake, no doubt. And I'm really surprised it did not produce a tsunami, but there are reasons for that. I did find out the reasons behind it. We'll go ahead and check that out real quick. Let's go back here on this USGS map here and check out just a few things here, and I'll kind of explain to you guys why I believe this did not produce a tsunami. Subduction zone, right? It's 8.2 in a major subduction zone. This thing should have produced a massive tsunami, like others in that region over the years. You can see the historical earthquake activity there, producing quite a few significant earthquakes within recent history. So let's go ahead and go down here to the fault description and the basically what they believe is the slip area and how it performed there in the subduction zone. Monitoring all the P waves and the broadband waves, some long period seismograph waves that were analyzed. And I'm not going to read all this technical information, because to me it doesn't even make sense most of the time. I kind of like to look at pictures, if you will. I kind of like to look at pictures, right? And here is a good diagram of where the slip occurred and the slip distribution, if you will, along the fracture area. This is the I wish I could zoom out from here, but this is the epicenter of the quake in the Alaska region. Once again, right around here. Okay, this is the plate boundary, the Pacific Plate subduction zone, North American Plate to the north. When you go, let's see if I can find out where that went to. There we go. Here's the subduction zone once again, the Pacific Plate to the south, North American to the north. Epicenter. Check out the slip distribution here. In a subduction zone, it's kind of odd that this kind of happened here. Normally in the subduction area, we see a north to south, or it doesn't matter where it's at. We see a vertical type dip, is what I'm saying, vertical slippage. Meaning in this case, it should have been north to south, right? With the plate boundary here, the subduction zone here. If that earthquake had struck north to south in that area where this highlighted activity is, this was different. Not west to east like this, left to right, horizontal type movement. We would have seen a major tsunami take place. Instead, this is what the USGS believes what happened. They believe, looking at and analyzing all the different waveforms of all the numerous equipment that they monitor, they come up with this conclusion here, that the slippage area, no doubt, was pretty much a left to right type deal in a subduction zone, possibly northwest to southeast. And it was a major earthquake, no doubt, a significant amount of energy released, but the dynamics of this earthquake and the slippage in this region of the subduction zone prevented a massive tsunami from forming. Very lucky. Had this been a north to south or a vertical type slippage in an average or normal typical earthquake in the subduction zone, man, it would have been pretty significant. So I'm trying to explain this the best I can. That's kind of why they put this out, to give an overview. I had a lot of comments asking why this did not produce a tsunami. And this right here is 100% the reason why it did not produce it. Had this been a 7.5 at a lesser magnitude with a more vertical type dynamic slippage, we could have seen a tsunami produce. But because of it being a horizontal type slippage in a subduction zone, that's why we did not see the water displacement and produce a tsunami from last night's earthquake. That's good, but it's still there's a lot of uncertainty here in this area. I was looking at. I want to show you guys the historical earthquake activity in the Aleutian Trench area. This is since records only go back so far, but this is since about 1900. 8.0 earthquakes and above. The 8.2 that struck last night is right there in the blue, right next to another 8-pointer. That's kind of odd, folks. That's very odd to see a couple 8-pointers right next to each other. Excuse me. But it does happen, especially in a built-up area such as the Aleutian Trench. The other earthquake, let's go back down here, was the 1938 8.2, roughly at 35 kilometers as well. See the depth there of those earthquakes? 32, 35. And no more than, I would say about 10 miles or so from each other. So they believe possibly that the last night's 8.2 earthquake ruptured into that area of the 1938 quake. Possibly. Almost all the way. Of course, this area of the Aleutian Trench area can see some mega quakes, folks. 8.6 back in 1946, and a much larger quake, the Prince William Sound earthquake back in 1964. Quite a few folks remember that. I was not born back then yet, but I've seen quite a few historical pictures and a lot of information on that earthquake back then that did produce a significant earthquake, including the 1938 one. That one produced a pretty good sized one as well. 1946. That one was a pretty good one. I remember that, at least reading a few articles. So let's go ahead and read what the USGS states here on this. It's kind of interesting to read this article. It's a tectonic plate summary about the earthquake that struck last night. We'll go ahead and read some of this. The July 29th, 2021. Of course, that was UTC time. Local time was my time, or close to my time. M8.2 earthquake southeast of Perryville, Alaska. Occurred as a result of thrust faulting on or near the subduction zone interface between the Pacific and the North American plates, as mentioned. The preliminary focal mechanism solution indicates rupture occurred on a fault dipping either shallow to the northwest or steeply to the southeast. That's kind of what you've seen in that image that I showed you, how it was going to the slippage. It was going to the northwest and to the southeast. So a little bit of uncertainty there. The location, mechanism, and depth of the large size of the event are all consistent with slip occurring on the subduction zone interface between the two plates. Quite a bit of built up over the years. Pacific plate converges with the North American to the northwest at a rate of 64 mm per year, subducting at the Alaska Aleutian Trench, 125 kilometers southeast of the earthquake. So that's pretty good amount of buildup for yearly accumulation. Large earthquakes are common in the Alaska Aleutian subduction zone. Here's the amount. They talk about the numerous earthquakes. The Alaska Aleutian Trench also hosted the second largest earthquake recorded by modern seismic instrumentation, the 9.2 March 27, 1964 earthquake, which ruptured to within about 250 kilometers of this event at the eastern end of the 1938 rupture. Of course, the 1938 event produced a small tsunami. Let's see here. What do we got here? So, this could have been a much worse scenario, folks, had this thing ruptured a little bit differently as far as the, once again, the plate or the slippage area. Just kind of odd. Kind of in that same area where the let me see if I can pull that up. I'm pretty sure I had that available somewhere. Is it this one? Yes. Okay. So this goes back to last year. There was quite a bit of significant earthquake activity within the area of where this 8.2 struck last night. Back in 2020, last year, around this time, July 22nd, 2020, there was a 7.8, roughly right around 30 kilometers as well, within the range of that last night's 8.2. A little bit later in the year, in 2020, there was a further rupture, 7.6, a little bit further away, but at the same depth below the surface into the subduction zone. So this is within the last year. Quite a bit of significant movement here taking place in that area. Could we see something bigger in this region? Possibly, but highly unlikely. I think at least we're probably going to see at least another 7.0 aftershock taking place in this region. So far, I believe the 6.1 is the standing champion, I guess that's a word, far as the aftershock sequences go. Far as the magnitude, that looks like that's about it, 6.1, and that one occurred just a few minutes after the 8.2. There's been another 5.9 after that, but the possibility of seeing something a little bit larger than 6.1 is highly likely. Like I said, we could see a 7-pointer, maybe possibly even a 7.5 in that region. If we do, and it's at a, these are all scattered about here. If you look at the swath of the earthquakes, they're all over the place. They're not really confined to around the epicenter. So it's something telling me that there's still an incredible amount of pressure along the Aleutian Trench area. It's definitely something to be on guard about, folks, as we could see a little bit further movement and larger scale earthquake in this region. If you notice, this is the, let's go ahead and make sure I'm at the right map. Yep, 2.5 and above. Look at the continued lack of earthquake activity still around the northwestern part of the Pacific Ring of Fire through that bend. Nothing. There's absolutely zero. Nothing going on. This still concerns me very, very highly. I'm pretty concerned about this region. We've been watching over the past few months all sorts of activity take place down around the New Zealand area and Tonga area. A lot of large-scale movement. I want to see if I can bring up the... I got a bunch of maps here. Let's see, 7.6. And by the way, that earthquake, the 8.2 that struck last night, is the strongest earthquake on the planet in 3 years. Look at the last one right there. The last 8.2 earthquake was in Fiji. Look at that depth right there, 600 kilometers back in 2018 for an 8.2. Prior to that, last sizable quake above that was an 8.3 in Chile back in 2015, but that's pretty significant. That's really significant. This goes back until about, 1900, 1905 or so. Look at all the subduction zones. Look at all those subduction zones. Seeing quite a bit of buildup. Look what's absent up here. Look at that major subduction zone along the North American plate called the Cascadia subduction zone. And there's nothing. Zip zero. That's the only part of the puzzle that's missing. As far as activity along the North American plate and the western states, we've seen a little bit of increase in earthquake activity here along the Cascadia subduction zone. Okay, this is not a release of pressure. This is increase in pressure, and it kind of bugs me a little bit because I don't believe we're going to see any type of relief from this 8.2 that struck last night. I just don't see it. It doesn't line up with the dynamics of the plate interactions. I think if anything, if we're seeing a release along the North American plate there, we would look towards the west, along the Japan area, Japan Trench, Philippine plate. Further movement to the west on those areas, I believe, could potentially release a little bit of pressure along the North American plate. But I just don't see it with this earthquake. If anything, I think it's possible we could have seen a heightened pressure out here along the west coast. Even though it doesn't really look like it tremendously, we're still seeing earthquake activity ramp up here in the southern end of the Cascadia. I'm going to show you the tremor map in a little bit, and I'm going to explain why I believe that. What I just said is so 22 kilometers for that 2.9, southern end of the Cascadia megathrust area. Also up here, a little 2.2, 6.8 kilometers. We have been watching some further movement here throughout the past few weeks. Not unusual to see earthquake activity in this region, but we have been seeing quite a bit of deep movement take place here recently. Into the Pacific Northwest, a little bit of movement around Mount St. Helens, and some deeper earthquake activity once again into the Olympic Mountains here west of Seattle. I want to show you guys real quick the tremor map into the Cascadia subduction zone. Check it out. So this is activity over the last day, 24 hours. This is activity after the 8.2, and we're seeing a heavily dynamic increase in subduction along the almost the entire area of the Cascadia subduction zone, from the north all the way down south here. Look at that swath of tremor along the Cascadia. So what happens when you get tremor? What causes the tremor? Pressure, increase in pressure, subduction, right? This is not release of pressure. This is not backflowing. This is not backing out. This is subduction, creating, ultimately, I believe, more pressure along the Cascadia subduction zone. So it's not surprising to see an increase in pressure here along the North American plate, the west coast, following that odd earthquake in Alaska in the Aleutian Islands area, Aleutian Trench area. What do we got? 373 epicenters of tremor. That's a pretty major increase prior to this 8.2 that struck last night. So if anything, I firmly believe that we're looking at heightened increased pressure, heightened earthquake, general earthquake plate tectonic action out here far as the buildup goes. It only makes sense because we are not looking at this wide area of tremor along the Cascadia prior to that 8.2. Also, let's go ahead and check out the activity in Yellowstone. So, do you think? Let me see here, guys. Do you think if there was a release of pressure here along the North American plate, a Pacific plate, North American plate are huge, super huge plates, folks. And 8.2 did quite a bit of release of pressure up here in this region due to the stress of this area of subduction zone. But there's ultimately a domino effect that takes place in any given area after any quake, especially with this size. Do you think that pressure has been released along the North American plate? Well, I just showed you guys the tremor, the increase in tremor along the Cascadia. And now I'm going to show you guys the increase in earthquake activity following almost immediately following that 8.2. Check out that. That's not a release of pressure. That's not backing off saying, okay, we're good now. We're not under a whole lot of stress. No, that's a seismically increase in pressure along the North American craton, the North American plate, the west coast. That earthquake activity showing up Norris Junction, Mary Lake area. This area right here is in the kind of like in the middle, if you will, between the swarming activity that we've seen over here, and you can see this activity too, ramping up of its own. But man, there's separate swarms going on here in Yellowstone. The Maple Creek area, Norris Junction, Mary Lake area, and the region below Yellowstone Lake. These are separate. But there's no denying that we've seen an uptick in earthquake activity immediately following that 8.2. And we can go back to the prior day and show you guys. It's not just coincidence. It is not just, well, just bad timing. You know, the swarm just happened to start right after the 8.2. No. There was thunderstorm activity in Yellowstone National Park. I kind of explained this signal, this little signature right here as well. But you don't see any earthquake activity, well-defined, specific spikes on any of these graphs. A little bit over here. But it doesn't really kick up until that large 8.2 makes a little adjustment and adds more pressure here to the west coast and the North American plate. There's no denying that. There's no denying that. That is the 8.2 that struck there. I tell you what, man, it shook the earth gave earth quite a rattle, if I can spit that out. So I firmly, honestly believe, folks, that man, there's just nothing. There's nothing that's gonna ease my eerie feeling about all this until this area kind of makes a little adjustment here to the west and possibly relieve some pressure out here along the west coast. You can see the movement all up and down the northern California, Cascadia megathrust area, down through the San Andreas fault zone, the creeping section. We're not seeing any swarming yet in Southern California. The dynamics of this whole area, I think right now, are stuck on the Cascadia. There is a lot of movement inland. Looks like Ridgecrest seen a little bit of uptick in activity. The area. Somebody said I wasn't pointing at the Antelope Valley. I'm not 100% certain, but on this map, if I read that correctly, Antelope Valley. That specifically says Antelope Valley. But yeah, that's kind of where I'm pointing at, unless my pointer's showing way up here. But this is the Antelope Valley area. And this is where we're seeing all that earthquake activity, aftershock activity ramp up from a couple weeks ago, that 6-pointer. There is some further movement here north of Lake Tahoe, 2.2 and a 1.0 in the Sierra Nevada near Truckee. Some of the activity reported on the USGS stations in Yellowstone National Park. That's good that they're reporting it. Most of it, no doubt, microquakes, but nonetheless, regional meaning as a whole. This area right here, North American Plate, making some major changes and whatnot due to that 8.2 adjustment. I don't think it relieved anything out here along the west coast at all. That's my honest opinion, at least my observation anyway. Pecos, Texas, seeing a little bit of movement. Oklahoma getting in on a lot of the activity. The New Madrid fault system quiet for now. Down on Mexico, Guatemala, seeing some activity in the 4 range. Nothing significant, and not a whole lot of movement in Chile area. Chile either. There we go. Let's go ahead and spit it out. I did not get much sleep last night, folks. I was watching the tsunami warnings and whatnot like crazy. But we are seeing some deeper movement once again into the Tonga area, Fiji area up here to the north. 603 kilometers for this 4.4. What do we got there? 482 for the other one. Pretty significant deep movement taking place since that 8.2 struck down here. But man, you know, I can't see a major whole bunch of plate movement adjustment taking place to the southwest here and up here to the north. And with the lack of activity here for months on end, something's got to give here in this region, or we're looking at west coast activity really possibly kicking up some large scale movement. It's there. The tremor movement, the earthquake activity inland into the interior up against the North American Craton. San Andreas Fault showing a lot of action. It tells me right there, folks, that we're definitely ramping up some stuff here along the west coast. Okay, I didn't want to turn this into a super long video, but I kind of had to explain about the tsunami, the effect of the or the lack of a tsunami due to the fault slippage area, the kind of horizontal type slippage in this region. You can see that the darker colors indicating more slippage, and the plate boundary here, epicenter at the star right there. I think we got pretty lucky. Had this been a little bit more vertical here, we'd be looking at definitely a sizable tsunami out there, but man, pretty lucky. Let's check out the volcanoes real quick in the Pacific Northwest. I don't want to view the event page. Just want to view a seismogram here. Yep, there's the 8.2 showing up pretty significantly there at Mount St. Helens. Prior to that, or at least after that, I don't see any significant increase in earthquakes, but there is an adjustment the following day, it looks like, that's picking up some microquake activity there at Mount St. Helens. See these spikes indicating localized quakes there at St. Helens. Let's check out Rainier real quick here and see what we got. Hello, McFly. Oh, there we go. Okay, so it's kicking up. Well, where is the 8.2? Wow. They should have showed up way more significant. Kind of similar to what you would see on the Yellowstone or St. Helens seismograph. They got this thing squashed down pretty good. So that means that these earthquakes here are... it means that, wow, quite a bit of earthquake activity. It looks like at Mount Rainier. Looks like maybe this might be the 8.2 there in Alaska. Looking at some of those waves, I believe that's it. But it's not really, it's not amplified. This seismograph station is not amplified to pick up light activity. So definitely earthquake activity taking place there in Mount Rainier as well, even though they're not really showing a whole bunch. This shows from the last 2 weeks, but definitely looking at that graph, there's more, definitely a lot more than what they're reporting here on this map. As far as number of aftershocks go, folks, there's going to be, I'm sure, a whole lot more. There's only 94 being reported so far, or 95, and I guarantee you there's going to be a lot more. I don't even see microquakes listed. It looks like they're maybe only doing 2.5 and above, even though this is the all magnitude map. I'm sure there's possibly close to I'm taking a wild guess, 600-700 quakes or so. Once they get caught up to it, that will be listed here on this map, because there's no way an 8.2 is only going to produce about 95 aftershocks. No way. Definitely a lot more. So while this is still quiet, folks, there's still 2 areas to watch, and I've been saying this every single video. Japan, West Coast. West Coast means Cascadia as well. I just don't feel like this is enough relief of pressure. If anything, I believe it's amplified the pressure dynamics here along the West Coast. That's my story, and I'm kind of sticking to it. Anyway, folks, have a good day or a good night. Stay safe out there. We'll be kind of monitoring everything and see how things go over the next couple days. Chat you guys a little bit later. Stay safe, everyone.